creating when it is attached to a compound which is conjugated. There is a resonance. So if a group G is attached and resonance is studied with respect to G, G is participating. Okay. Good evening. Good evening, Mariam. You're welcome. Now, are you in a position to hear, Mariam? Are you in a position to hear? Please let me know, because we have just made some small changes in our system. Please let me know, Mariam, if I'm audible. Anybody can respond me if you are hearing me and I'm audible, because we just wanted to know the quality of broadcast also. That was our most essential step, and that we always do in the beginning. Please let me know. Okay, I am moving ahead. If at all, yes, sir. Okay. Thank you very much. Thank you very much. Thank you, Mario. Thank you for staying with us. We just told about the mesomeric effect, and a very small thing that we have said. What a small thing that we have said. Earlier we studied about inductive effect, and we told you that if there is a carbon chain and if there is a group attached here, let us say X is attached here, either it can push electron or it can pull electron through sigma electron transmission, and that we understood as inductive effect, sigma electron transmission. But now here we are altering the situation. Now instead of a straight chain, we are taking a conjugated system where already resonance is present. And if now there is a group that is present, so the group, if a group G is attached and resonance is being studied with respect to G, G is participating in resonance, we understand mesomerism is being applied. I hope to some extent you have understood mesomerism. I will be elaborating it further. Okay. Let us try to understand. I have taken two examples. In one case, I have taken a benzene ring, and as you know, benzene ring generally is represented like this, and we have a system that is NH2. Here lone pair of electron is present. And I am taking another system also that again is connected with benzene ring, and here we have taken NO2. Now, when the study of NH2, it is conjugated with this aromatic system. Benzene is an aromatic compound. Resonance is there. Aromaticity is also there. It is a conjugated compound. Now look here. NH2 is attached with this conjugated system. Here NO2 is also attached with the conjugated system. Now if we are studying about the property of NO2 and NH2 with respect to this benzene ring, we will call or we will understand this phenomena as mesomeric. Because it can do two things. Either it will send electron or it will push electron, it will pull electron. These are the two things that can happen, and we are interested in that only. Pushing electron or pulling electron. The pushing phenomena of electron will be called as positive mesomeric effect. Pulling phenomena will be called as negative mesomeric. How the resulting structure will be formed, that we will be doing later, but let us first try to understand what actually the mesomerism phenomenon is, and secondly, how many types of mesomerism can happen like this. When the group increases the electron density in the conjugated system, it is said to exhibit plus M effect, and if it decreases the electron density in the conjugated system, it shows minus M. Fine? Okay. Moving on. Consider an example of phenol. Besides NH2 and NO2, I have taken an example of phenol and letting you understand how actually is happening. Charge separation has been created. Now look here. This OH, C6H5OH, O has got two lone pairs of electron. Now this electron will be moving. This is how we will be forming resonating structure in phenol. This electron will be going to this particular bond. There will be a double bond that will be formed, and this electron will be coming from this place to this place. So negative charge will be coming to this. Here there is a negative charge. In the second step, this negative charge is coming to this place, and this bond will be shifting to this place. So we will be having a negative charge at this place. So negative charge at this place in the first place, negative charge at this place, and in the third situation we will be having negative charge at this place, and finally it will be reaching to this final thing, and this will be like this. So what generally we have seen, OH has got a property to push the electron into the system. As a result of all these resonating structure, which is also called as canonical structure, look here how the charge separation will be created. How the charge separation will be created. On OH, we will be having a positive charge, delta positive charge. Why we will be having a positive charge? Because electron has shifted from that place. Electron has gone from that place. So there will be a positive. And all those positions that I have mentioned, there will be a partial negative charge at this place. So charge separation has been created, and it has increased electron density in benzene ring. The OH is showing positive mesomeric effect. Now I hope the things have been started getting clear to some extent. Let us consider another example. We are taking hereby another example where we are taking a situation of pulling phenomena. It can be seen that electrons are being withdrawn. I have taken an example of what? This is a carboxylate ion. This is a carboxylate ion. Look here. We have done like this. C double bond O. No, I'm sorry, it's not carboxylate ion. It's an aldehyde. Benzaldehyde is there. So again, what will happen? Oxygen has got lone pair here. This is lone pair. In this situation, what is happening? We generally observe electron is moving from this place to this place. Look here, electron is moving from this place, and this electron is coming from this place, leading to a positive charge at ortho position. Further movement or further resonating structure, a positive charge at para position. Again further moving, again at ortho position, positive. Here what we have noticed, CHO, it has got a tendency to pull the electron. So it can be seen that electrons are being withdrawn. Therefore we can say that when resonance is being studied with respect to a group, mesomeric effect are observed, and it is a relative term. Very important information. Plus M and minus M are relative terms. Look here, I would like to point it out. We have a group OH and we have a group, this is a phenol. In another situation, we again had a group and we again had CHO. Now let us try to understand these two things. Here we said it is creating plus M. Then obviously it will be creating minus M effect. If it is pushing the electron, then obviously benzene ring will become minus, creating minus M effect. Here CHO, we said it is creating minus M effect. Then now this benzene ring will be creating plus M effect. So if somebody asks whether the phenol ring will be showing plus M effect or minus M effect, it is always a relative concept. Always remember, if one substance attached to it is creating plus M, the another substance obviously will be creating minus M effect. Right? Same is the thing that we have written. It is a relative term, plus M and minus M. If CHO group is showing minus M effect, then benzene ring is showing plus M effect. In both the cases, the things can be understood then. Coming to another slide. In general, how will we identify that a particular group or a species will be having a plus M effect or a group will be having minus M effect? And it is very easy to identify. Very easy, believe me. Look here. We have a system that is conjugated and we have attached a substance. Look for a lone pair. Look for a lone pair. Lone pair on which? Lone pair on the species which is directly attached to this carbon. Directly attached. You have not to see the lone pair of electron in further atoms. You have to see lone pair in the immediate atom. Right? If in the conjugate system the immediate species that is attached is having a lone pair, it will always show plus M. Plus M. The situation can be even like this, lone pair with a negative charge. This can also be possible. Again, this will also showing plus M. If the first atom has a lone pair, first atom, when I am saying first atom which is attached, it will show plus M effect. It is also shown by negative charge with unshared electron pair. Negative charge with unshared electron pair. Both of them show positive mesomeric effect. It will have a tendency to pull the electron. Got the point? Okay. Moving in. Is it audible now, Sudha? My voice is audible? Are you in a position to hear me? Can you please check? Can you please confirm? Mariam, also you can respond. Are you hearing me? Sudha to respond. If I am audible or not. Okay, I'll be audible. Don't worry. But you need to respond. You need to respond me. Okay. Now, looking at minus M effect. Minus M effect. We talked about plus M effect. Now we are talking about minus M effect. Minus M effect is what? It's a pulling effect. Plus M effect was what? Pushing effect. Minus M is pulling effect. Now, if you find these two situations, there is a conjugated system, and if you find a double bond here. Conjugated system, if you find a triple bond here, then in that situation, what will happen? Generally, they will have a pulling effect. And in this situation, electronegativity of Y should be greater than electronegativity of X. This has to be borne in mind. If this is more electronegative attached with a double or a triple bond, then electron, it will start pulling and it will show minus M effect. Right? Okay. Before I move ahead, I would like to let you know about Altedemy and will invite you to be the part of this family. The courses that we provide, it contains 90 plus classes. The convenient educational platform. The syllabus that we are giving, it is by NEET expert. We have flipped classroom methods. We have doubt solving practices. You can join us to avail great advantage. How is the flipped classroom that looks like? That these are the things that these are the special features that you will come across. Whenever you are studying a particular chapter, particular webinar that we are conducting or particular class you are having, before the class you will be getting the study material, the theoretical study material that you will be getting. Apart from that study material, the uh, the PPTs that we are giving, that also is a part of our study material where we are discussing the things in detail, and obviously our discussions are involved there. Apart from these, we also conduct webinars as we are conducting it right now to picking and choosing selective topics and going detail into it so that you understand the intricacies of this particular. Apart from all those things, you also get homework, plenty of homework you get with each and every session you get homework. The analysis of homework is also being done by us regularly. Homework checking is also being done, and then you need to practice regularly to go through your syllabus, to complete your syllabus. Moving ahead, we have built up many programs. When you subscribe to NEET or JEE program, like we have three different programs like light program, smart program, and proficient program. In the light program, we have the special features of interactive live classes, structured courses and PDF, live tests, and physical notes. These are our special features that we give to a live class. We have smart classes. In smart classes, we provide interactive live classes, structured courses and PDF, live tests, physical notes, 1:1 mentorship. This is very important. We have live doubt solving questions also. We conduct mock tests regularly. And besides our smart class, we have also got proficient class, where in addition to all those things that we discussed, interactive live classes, structured courses and PDF, live tests, physical notes, 1:1 mentorship, live doubt solving, mock tests regularly, we also give additional special courses when you want to, when you think that you have completed your syllabus and you want to know more, you can choose a proficient program. However, I'll suggest you to go for a smart program. That will not be a burning a hole in your pocket. Okay. Moving. The three situation I am taking. The three situation. For understanding the actual fact lying with plus m and minus m, why some species will be of pushing nature and some species will be of pulling nature, it lies in the understanding of these three things. Lies in the understanding of these three things. Apart from the situation that we discussed, suppose we have a situation like this, as I am writing here, X double bond Y, a conjugated system XY, and again writing CH double bond CH, CH double bond CH, and now we have Y with a positive charge. Y with a positive charge. You need to note it down in case you are watching me. CH double bond CH, CH double bond CH, and we have a species like BH2. All of them are minus M, showing minus M effect. Why? You should understand. Even this has got a vacant orbital. Even this has got a vacant orbital. So what will happen if a vacant orbital species is connected with a compound that is conjugated? When a vacant orbital is present, it is creating an opportunity for electrons to get accommodated in those vacant orbitals, and therefore it is working as a minus M group, right? So plus M and minus M has got some logic into it. First thing, that if Y is more electronegative than X and Y and X are attached with each other, Y and X are attached with each other with a double bond, then obviously it will have a nature of electron withdrawing. And besides this, triple bond also, you can say, triple bond is also unsaturated state. Similarly, if there is a positive charge with a vacant orbital, All positive charge need not be having a vacant orbital always, as I'll give you some examples. But there are some species which will be having vacant orbital, as is the case with BH2. Moving ahead, let us try to identify what kind of effect the following species will be creating. Just to remind you, we told you 5 things. First thing that we said, plus M lone pair. Second thing that we said, plus M negative charge with lone pair. Third thing, minus M double or triple bond. Fourth thing, minus M positive charge vacant orbital. And fifth thing again, minus M vacant orbital only, vacant orbital. And keeping these things in your mind, you can identify. I am giving you plenty of species. Like if I am saying minus O, there is a negative charge and a lone pair, unshared electron pair. Negative charge and unshared electron pair. This is going by definition only. This is plus M. Again, same is the case with NH, plus M. OH, though it has not been shown, but then you will have to understand it has a lone pair here. Then obviously if it is having a lone pair, plus M. NH2, sometimes the lone pairs are shown, sometimes the lone pairs are not shown. It is showing plus M. OR, plus M. OH2, look here, be careful. You might say that there is a positive charge here, but here you should remember, positive charge be there with a vacant orbital. And if there is a positive charge with a vacant orbital, then only it can show minus M. So it is not showing minus M. There are no chances of plus M. Minus M plus M both are not being done. The only thing that it is doing, it is creating minus I effect. It is creating minus I effect. So you need to be very careful. You need to understand it. Why? Look here. If you are saying HOH, right? Here it has got an electron. It has got an electron. The lone pair of electrons. Now, oxygen as such has got 8 electrons. So configuration is 1s2, 2s2, 2p4. Look at the configuration of 2s, 2 electrons, 2p4, 2s2, 2p4 electrons are there. Now, if you are removing one electron from here, because the last electron will be removed from here. If this electron will be removed from here, then obviously there won't be any vacant orbital here. Vacant orbital is necessary. Vacant orbital is necessary. There is no vacant orbital in OH2 plus. There is no vacant orbital in NH3 plus. You should also know. There is no vacant orbital in NH3 plus. So it will not be showing this. Again, same is the case with OR2. Same situation. It is not showing plus M or minus M. It will be showing minus I effect. Let us do some more such thing, because it will clarify your doubts regarding plus M and minus M. Identifying a species or group, whether it is showing plus M, minus M or something else, it is very important. Again, I gave you the example of NH3. It is showing minus I effect. As I told you, no vacant orbital. NR3 again minus I effect. But yes, SH, it is having a lone pair of electron. When it is having a lone pair of electron, obviously it can donate a lone pair of electron. So we'll say it is showing plus M effect. SH2. Now you should understand, oxygen may not have a vacant orbital because it has last electron in the second shell and all of them are occupied. But sulfur, on the contrary, it has got a vacant orbital. Vacant orbital, unoccupied state. You just have a look. Sulfur, atomic number is what? 16. 1s2, 2s2, 2p6, 3s2, 3p4, Now look here, the moment we said third shell, 3D came here. So it will be having vacant shell. So when it will be having vacant shell, then positive charge and a vacant shell, yes, it will show minus M. Very important. pH2, phosphorus, it has not been shown, but it is having a lone pair of electrons. It will show positive mesomeric effect. pH3, now again nitrogen does not have a vacant orbital, but phosphorus has a vacant orbital. And having a positive charge and vacant orbital, it will create minus M effect. I hope you are getting to the point. You're understanding it. Write me. You can choose to write plus if you are understanding. You can give me a symbol minus if you're not understanding. I'll be happy. I'm just trying to making you understand which groups can you call as positive mesomeric effect, which groups can you call as minus, showing negative mesomeric effect. Positive mesomeric effect means that will be donating electron towards benzene ring or towards a conjugated system. Minus M, which will be withdrawing electron from the conjugated system. Plus PR3, again minus M, it will be having vacant orbital. NO2, minus M, it is having double bond. NO2, as we said, N double bond O, NO2. Look here, C triple bond N. We told you with a triple bond also we have minus M property. OCOCH3, the conjugated system is attached here. You have to understand this. Conjugated system has to be attached here. Now in all such situation, though CO group is an electron withdrawing group, but here oxygen is having lone pair of electrons. And the group which is immediately attached to the conjugated system has to be seen. So it will be creating plus MF. Same is the case with NHCOCH3. Bear in mind, CO is electron withdrawing group, but we have to see this group which is attached to the conjugated system. Here also, here there is no such group. If a benzene ring is directly attached to it, now this C, you can clearly understand it is an electron withdrawing system. So it is having a negative mesomeric effect. Same is the case with CONH2, negative mesomeric effect. COOH, minus M effect. CHO, minus M effect. COR, minus M effect. CONHCH3, minus M effect. Now just try to understand. What are the groups that you are going to study in your organic chemistry? Can you let me know which are the groups that you are going to study? You will be studying halogens, haloalkanes, haloarenes. You will be studying alcohol. You will be studying aldehyde. You will be studying ketone. You will be studying carboxylic acid. You will be studying amine and its derivative. And here we have covered each and every such species, right? Each and every such species. And I hope you will be in a position to do justice with it. Now, moving on. There are some groups which show both the effect, that is plus M and minus M both. There are a few groups. To name some of them, I have mentioned here. NO, it's a group NO. It shows both the SH. It creates both the effect. How come both effect? Look here. It is having lone pair of electrons. That is the first thing. But secondly, it is having a vacant. It is having a vacant orbital also. It is having a vacant orbital also. So if it is having a lone pair as well as vacant orbital, it will show both kind of effect. Similarly, we have CH double bond CH2. CH double bond CH2. This also shows both kind of effect. N double bond NH. It is having lone pair as well as the double bond, presence of double bond. pH we have seen, it is showing plus M as well as minus M. NC is a triple bond, N triple bond C. So these are very special cases. where both plus M and minus M effect both are being. Now, I have written a very important statement and you should follow that statement. First thing, it should be noted that plus M dominates over minus M. As I told you, there are a lot of species which show plus M and minus M both. And somehow or the other, if you identify that this species is creating positive mesomeric effect and negative mesomeric effect, then which of the two will be dominating? Always understand that plus M dominates over minus M, because what we say that plus M is a complete octet resonance. Very important statement. Plus M is a complete octet resonance and minus M is an incomplete octet resonance. I will show you with an example. Let us take an example. CH2. We have taken this. CH double bond CH2. We have a double bond here like this. Now, if you will be showing the resonating structure, you will find that if it is showing plus M effect, if it is showing CH2 is a group, as I have told you, it is showing both the effect CH double bond CH2. You may ask why. I'll explain you later why CH2 will be creating both. Suppose it is creating a positive mesomeric effect. It's an electron rich molecule, and electron rich molecule will have a tendency to transfer the electron. Suppose it is doing that. So what will happen if the electrons are being transferred from this particular double bond to this particular thing? Then what will happen? At these three places negative charge will be created. If it shows plus M effect, then at three places where negative charge is coming, their octet is completed. As I tell you, look here. If we write CH3 plus and if we write CH3 minus, what do you think? Which of the two has completed its octet? Naturally, this has completed. It has not completed its octet. So, if a negative charge is present at these carbon atoms, obviously it has completed its octet. But if it is showing minus M effect, in case it is showing minus M effect, then at these ortho and para position, what will happen? There will be positive charges here. And obviously it will not be completing its octet. And therefore, nothing is more stable than the octet situation. We say that plus M is a complete octet resonance and minus M is an incomplete octet resonance. That is why plus M dominates over minus. Okay, I hope you have enjoying the session. Okay, some important guidelines that I am going to give. Those groups which show plus M and minus M, then their plus M is more dominating than minus M. We have discussed about this. Next thing is, plus M of any anion is greater than any neutral. Plus M of any anion is greater than any neutral. And minus M of any cation is greater than any neutral. As we can see plus M, if we compare this with this is a charge, anion. This is a neutral species. If it is a charge species, then the plus M effect of minus O with a minus O negative, this will be greater than OH. Minus M of PR3 plus and CHO. Look here, minus M of PR3 will be greater than that of CHO, neutral molecule. So these are two very important points worth noting. What will happen? Charged species will always be having the extent of plus and minus M, negative charge plus M effect, positive charge it's having minus M effect. So the extent will be great when it is charged. Okay. Mesomeric strength is directly proportional to the strength of overlap. More the overlapping, extent of overlapping, more will be the effect of mesomerism. Like here, if we compare OH on one hand, SH on other hand, the plus M effect of OH is greater than plus M effect of SH. Why? Because the conjugate system with which it will be attached, the extent of overlap of oxygen will be more in comparison to sulfur, because sulfur is a large molecule, right? M effect occurs through resonance. It is more than clear now. It is observed in conjugated system only. It is distance independent effect. I mean, in relation to inductive effect, we had told you that it is distance dependent effect, but it is distance independent and is realized till the end of the chain, provided the conjugation is maintained. Plus M and minus M both have capability to form a new bond, where opposite plus M and minus I are present. It is quite likely that a group which is attached here, it is showing plus M on one hand and minus I on the other hand. It is quite possible. Where opposite plus M and minus I are present, M always dominant except in case of halogen. This is very important point. If you find, I had given you the order of inductive effect also, I will be giving you the order of mesomeric effect also. In case if you find a situation, like let us have a situation like halogens, we are saying, they have lone pair of electrons. Just because they have a lone pair of electrons, they are attached to a conjugated system, we can say plus M effect. But fluorine is more electronegative than the carbon, so you can say it is having a minus I effect. So it is quite possible that a species which is attached to a conjugated system is having plus M and minus I effect, and both are operating in opposite direction. And if this is happening, excepting halogen, in all other cases, plus M is always dominating over minus M. Mesomeric effect is always dominating over minus. As you can see here, the cases NH2, C6H5 NH2, they are showing plus M and minus I effect. But plus M will be dominating. OH, it will be showing plus M and minus I effect. But plus M will be dominating. OCH3, it will be showing plus M and minus I effect. But OCH3 will be dominating. Got the point? Consider a case of C6H5 NH3 plus. Now, as I told you, no plus M, no minus M. No mesomeric effect. Because there is no vacant orbital. It has a positive charge, but there is no vacant orbital. So there is no M effect because lone pair is not available here. So it will be having only minus I. Why minus I? Because nitrogen is more electronegative than carbon. That's why it will be pulling the electron. Coming to another aspect, we are taking the case of C6H5COH and C6H5CHO. This one is called as benzoic acid, another is called as benzaldehyde. Both have minus M and minus I effect. Look here, minus M and minus effect. But minus M of COOH is less than minus M of CHO. Minus M of CHO. This we should remember as a fact. Minus M of COH is less than that of this. So what kind of creation it will be doing? It should be made clear here. Same is the case. We can take another case like pH3 plus. pH3 plus, it will show minus M. You can clearly understand that it is having electron withdrawing tendency because it will be having vacant orbital. And SH shows plus M and minus M effect both because of vacant orbital and lone pair. You have come to a species which is having plus M and minus M, right? And where plus M and minus M both effects are operating, you can always say that plus M is more dominating than minus M. right? So primarily it will be treated as plus M effect. Look here, consider the case of halogens. In halogen, on the contrary, minus I is dominant than plus. This is the only exception that happens. In halogen, minus I is dominant than plus M. In both the cases, minus I is dominant more than plus M effect. But chlorine also shows minus M due to vacant d orbital. Look here, it also shows minus M. So whenever you are dealing with these species, you have to bear in mind whether they are having some kind of vacant orbital or not. And vacant orbital, how can you find out? Write down their configuration. If they are falling in the third and fourth period, then obviously you can say they will definitely be having some kind of vacant orbital. Moving ahead, let us solve some questions. Arrange them in their mesomeric power. OH, OR plus M of OH is greater than plus M of OR. Very, very important example. If you remember, we had told about inductive effect, minus I effect. In minus I effect of OR is greater than OH, but plus M of OH is greater than plus M of OR. Can we justify this? Try doing it. Try to apply the electronic theory. You will find out. If you cannot find it out, remember this example as a rule. Look here, this is the most important thing in this entire lecture. We have decreasing order of plus MC. NH2 minus, O minus, here we have this, NH2, NHR, NR2, OH, OR, OCOR, NHCOR, ClBr, I, hyperconjugation, PHNH. Right? Negative charge species are more having plus M effect. Now, which are the species which are having minus M series? This you should remember as a rule. All positively charged species, Pr3 plus, AsR3 plus, NO2, Cn, CHO, COOR, COOH, CONH2, COO minus, SO3H. All these species show exclusive minus M series, and it is in this order. It is in this order. You should remember it, right? CHO is having good amount of minus M capacity. Let us solve some another question. Arrange them in their mesomeric power. pH2 plus, pHr plus, Pr2 plus. And as I had discussed about NH2 and all those things, here logic of NHR will not be applied, because here distance factor is dominating. All of them are creating minus M, all of them have got vacant orbit. So in this situation, the mesomeric power 1 is greater than 2 is greater than 3. Remember this also as a rule. You may come across. Look here. NHCOR, OCOR. Arrange them in the order of their mesomeric power. Here plus M effect of OCOR is greater than NHCOR. So amides are nearly neutral molecules. Amides are nearly neutral molecules. Which is amide? This is amide. So 2 is having more than 1 plus M effect. Right? Here CO group, it will be electron withdrawing. So in that situation, plus M effect of OCOR is greater than NH. Plus M effect will be more than that. Let us have a very beautiful question. Arrange them in their stability order. Look here, we have formed some species and we have given you the answer also. Can you justify? Here CH2 plus is the reference. CH2 plus is the reference. OH at para position, OH at meta position, NO2 at para position. If OH at para position, this is creating plus M effect. NO2 from para position, it is showing minus M effect. NH2 from meta position, Nothing, it is minus I effect. SH from para position plus M effect. So this is what is happening. Again, OH, this is minus I. So if we have to arrange it in terms of, stability order, the species or the electronic property which is withdrawing electron, it will making it further unstable, and the one which is donating electron will definitely stabilize the positive. So we can say one is most stable because plus n group are OH and SH, and plus n power of OH is greater than SH. So one will be the most stable. Second comes the fifth. 1 is greater than 5, 1 and 5 will be there. Then comes second. Second is what? Second is minus I effect. Second is minus I. OH is creating minus I effect. What about fourth? What is fourth doing? Fourth again is doing minus I. This is with NH2. And then comes the third one. This is NO2, which is creating minus N. NO2 will be creating maximum, right? NO2 will be creating maximum. Okay. Coming to the last question, I think this is by and large the repetition of the question. Okay, we'll come more onto this. Thank you very much for watching this video. We will request you to join this our Telegram channel, so that you can come across plenty of things that we are giving. We are giving you PDF materials free of cost. We are giving free classes. We have plenty of announcements that will be of your concern. There will be some discounts and prizes that will be there for you as an offer. We conduct free classes regularly as webinars. We are conducting, as we are conducting it right now. We conduct free classes regularly. So we request you to join us. Join our, this Telegram channel, and that is completely free of cost. You can join as soon as possible. Thank you very much. See you soon.